Hello guys, so we're going to go over examples 3, 4, and 5 from chapter 4.1. Pretty much example 3 states, find the missing side length. Find the missing side length. Now in the previous examples, we were using the other two sides to find the third missing side. But now they're only giving you one side, an angle, and they're telling you what side they want. So, we can't use Pythagorean theorem to solve this because, again, I'm only given one side. So what do you do to solve this? You need a calculator, and you also need to know a little bit about identities. Again, since this is the reference angle and they're giving me the hypotenuse, I have to use an identity that both includes the hypotenuse and also the side adjacent to this angle. And we know that it would be cosine. Cosine is adjacent over hypotenuse. We could also use secant. Secant would be hypotenuse over adjacent. Now, I always find it easiest to have the variable of the missing side in the numerator, because to isolate, all you have to do is send this up here. We're going to go over that now. So try to use the identity in which the missing side would be the numerator, just to make your life easier. You're going to get the exact same answer using, any of these, but it's easier if the variable is in the numerator. So again, looking at this example, let's fill in what we know. Now, in the previous two examples, we were using cosine theta. Theta meaning, a variable that holds an angle, any angle or a variable angle. Now they're actually giving us a measurement. So I would be using cosine 42 degrees equals adjacent over hypotenuse. And in order to find the missing side, all I have to do is isolate my x. I multiply both sides by 18, and that's it. So how do you plug this into the calculator? You hit cosine 42 degrees, bam, and then multiplied by 18. Now note, we are using degrees. I'll say it once again. You go to your calculator, you hit mode, and you make sure you are in degree form, not in radian form. When we work with radians, you have to go over to radian form or radian mode under modes. When we're working with degrees, you use degree mode. If not, it's going to be incredibly wrong and you won't get any points. I'm going to repeat this every single time we have a test, etc., but it's your job to make sure you're working with the proper units. If we're given degrees, you go to degree mode. If we're given radians, you go to radian mode. We haven't gotten into radians yet, so just focus on degrees for the moment, okay? And yeah, just focus on degrees for the moment, but make sure it's in degree mode. So again, you do cosine of 42 degrees, enter, it's gonna give you a value, you multiply it by 18, and it's gonna give you an actual value, not a ratio. And that's the value of the missing side, whatever that would be. And that's how you find the missing side given an angle and a side. Okay. Now, example 4. All example 4 is talking about is finding the missing side in real life. And we will do word problems like that. It's the exact same thing, just in word problem format. So just make sure you briefly review it, look at it, see more or less what it's like. We will be doing word problems in class. The last example we're going to go over today from 4.1 would be find the missing angle measure. So, we've been given two sides, we have been able to find the third side and all our identities. Given an angle and a side, we have been able to find a second side. And once you have that, you can find the third side and all the identities. Now, what they're gonna do is, they're gonna give us two sides, and we have to find the angle that is between those sides. So let's look at the example they have in the book. They have a triangle that's like this. Remember, the hypotenuse is always opposite to the right angle. Here it's obvious, this is the longest side. When it's not obvious, look at the right angle. Opposite to that is the hypotenuse. They're giving us, this is the reference angle we have to find. This is an 11 and this is a 26. Now, just like the previous problem, they're giving us this reference angle, and according to this angle, well, okay, mathematically, it's not an actual reference angle, that's an actual definition. You will get to know later on this year, but we're using this angle as a reference, which isn't the same thing as a reference angle. We're using this as a reference, so given, they're asking us to find this angle, this would be adjacent, and this would be opposite to this angle. So I have to find the identities that use adjacent and opposite. I cannot use one that has hypotenuse because I'm not given the hypotenuse. So in this case, I could use tangent or cotangent. In the book, they use tangent. Tangent of an unknown angle, tangent of theta, is opposite over adjacent. Tangent theta equals opposite over adjacent. Now what you're gonna do is, in the calculator, I believe on the lower right hand side, there is an inverse button, which has the same identity, only it says it like this, for example, tangent -1, or it has cosine -1, or it has sine -1. That's just the inverse. So what you're gonna do is, given the sides, to find the angle, you just do the inverse of the ratio of those sides. So I'm gonna do tangent inverse 26 over 11 on your calculator. You're gonna hit enter, and that's gonna give you a number, and that's the degree of the angle made up. Oh, not made up. That's the degree of the angle in the that we have as a reference. Because sometimes we're not given the sides that are next to the angle. We might be given other sides. And that's pretty much it. So in the book, it says about 67 degrees. That's more or less what you should get. So again, to recap real quick, if I'm given an angle, 30 degrees, whatever, and I'm asked to find, for example, this side right here, again, in this example, we use opposite and hypotenuse. We can use sine. Sine, our variable is going to be in the denominator. I'm going to just use cosecant better. Cosecant would be hypotenuse over opposite. Cosecant theta. Cosecant of 30 degrees will be equal to x over 5. The 5 comes here multiplying. In your calculator, you do cosecant 30 multiplied by 5. Some calculators do not have that function, but you should know it. It's the inverse. Just isolate properly, and that's the answer. Okay, not that difficult. And when you're given two sides, to find the angle in between, again, let's do another example real quick. Let's say I have this triangle. And they give me 7 and 5. They're asking me to find this angle. Here I have an adjacent and the hypotenuse. Adjacent and hypotenuse would be cosine. So I'm going to do cosine of the angle I'm trying to figure out, theta, will be equal to adjacent over hypotenuse. What you're going to do is, in your calculator, you're going to do the inverse of this ratio. And it's going to give you the angle that is made up, or it's going to give you the angle that they're referencing. That's pretty much it for today. Tomorrow, we're going to do the last two examples of 4.1. Then we're going to continue working. Have a great day. I'll see you tomorrow. I'm going to upload the previous video later on today or tomorrow.